Welcome to the second day of the Eyes on Earth online roadshow. My name is Martijn Seiger and I'm your host for today. Yesterday we shared a lot of information on the Copernicus system and services. In this session we let the company Planet inspire you on how they innovate with satellite systems and data. Please submit any questions into the Q&A text box on your screen. After the presentation of Luis Peraza, he and his colleague, Dr. Rene Griesbach, will answer a selection of questions. Luis, the floor is yours.
Good morning, everybody, and welcome to our industry inspiration session at the Eyes on the Earth virtual roadshow. I'm Luis Peraza, and I'm joining today from Berlin, and I'm here representing Planet, the company where I work as a professional services engineer, where I help customers understand and use our products by conducting product training sessions and workshops, doing consultancy, but also by developing data and integration services if the customers need to. I'm very happy, and we at Planet are very excited about participating in this year's virtual run on the show, especially under these circumstances. So I first wanted to thank you for joining our session today and for adapting to this fully virtual conference format. I have prepared a short overview for today, so I can walk you through first some of the background on Planet as an Earth observation company, what are some of the solutions that we bring to the community, and how you can have access to those solutions. Then we will move to a pre-recorded short demo on our Explorer GUI so that you can learn and see how you can visualize and analyze data directly from your browser. And then we will finish with a live Q&A session where I will be joined by my colleague, Dr. Rene Griesbach, who will be joining from Brandenburg to try and answer questions that you have about Planet, about our data, our satellites, platform, and also about the presentation in general. So let's start. Planet is a company that integrates aerospace and data analytics, and by doing so, we operate the largest fleet of Earth observation satellites ever, which have collected and collect until now a massive amount of information that allows us to see for the first time the changes on our planet on a daily basis. So going into a bit of history on the company, Planet was founded in 2010 by a team of ex-NASA scientists in California. I'm not kidding when I say that it was founded in a garage. Their vision was to make small CubeSats with off-the-shelf but highest technology payload and launch many of them to distribute costs and risks. They managed to start with that around 2013 when the first early Dove satellites were launched into a sun-synchronous orbit. And by 2014, the company had a business plan materialize, including a mission one, which was followed by more launches and the acquisition of Blackbridge, which was the company that in 2015 was managing the German constellation of rapid eye satellites. The mission the Planet had set itself up to is this that I'm showing in here I think, to image the whole world every day, or every single day, and thus making change visible, accessible, and actionable. Moving on, in 2017, Planet acquired Terra Bella, which was the company managing Google's high-resolution satellites called SkySat. And also, and I think most importantly, on that year, we launched 146 satellites to essentially complete our mission one. From that point on, we kept working to improve our data and platform by including analytic feeds, so we can deliver them not only pixels, but also insights of the change. And we have continuously upgraded our technology on the satellites to improve the resolution. So this year, our goal is to make our data much more interoperable with other data sets, such as open data sets like Sentinel-2. So last, I wanted to show you how Planet's journey has been throughout the years, but measured by the area collected daily by our satellites in square kilometers. In this graph here, as you see, there was a big jump in 2017 where we launched 88 satellites and then 48 satellites. And since then, we have kept our collection around the 300 million square kilometer benchmark. And that, by the way, is the landmass of the Earth. And also here at the bottom, the time scale, it's daily frequency. So at Planet, we follow a concept called Agile Aerospace, and I'm sure many of you are familiar with the Agile development approach, or Agile everything for that matter. But that means that, when we say Agile, that means we do a lot of iterations in our company. And Well, that goes as much for software as it goes for satellite production. We've managed to build or to have 15 builds of satellites in 3 years. And each iteration means the technology and the satellites are better than the previous one. Following this approach, we've managed to upgrade our technology much faster than traditional satellites would. We've managed to catch up with changes on the market real time, and we've managed to take advantage of launch developments and also to fix issues in our satellites and constellations. As of today, this is how our constellation looks like. We have around 100 doves in orbit. We call that constellation Planetscope. They have 3.7 meter ground sampling distance, which means the images can be downsampled to 3 meter spatial resolution, and that's our flagship constellation. It is an always-on constellation. I'll talk a bit more about it in a second. Then we have our very high-resolution SkySats, of which there are now 15 satellites in orbit, and these have a resolution of 0.72 meters, 72 centimeters, and we are working to make that half a meter soon. And last but not least, we have the legacy rapid eye satellites, 5 of them. They are still alive, but they're not imaging anymore and have been decommissioned. But they image for about 10 years, the whole Earth, and we have a huge archive of 6.5 meters spatial resolution images on our platform, and those are very useful still for precise agriculture, for instance. Following what was mentioned about Agile Aerospace, our current Planetscope constellation consists of 3 different instruments resulting from various iterations, each of them more interoperable with Sentinel-2 data as the previous one. All of them interoperable with each other, of course. As you can see in the wavelength graphs shown in here, the top representing Sentinel data, or the Sentinel bands, and the following representing each of the Planetscope sensors. So we have Dove Classic, Dove R, or like Dove Refresh, and Super Dove. You can see that the wavelengths of the red, green, blue, and near-infrared for our Dove R and Super Dove sensors match those of Sentinel much better than with the previous sensor. So that's as a result of our efforts to make interoperability a thing. As a matter of fact, we're not only harmonizing our radiometry to Sentinel, but we're also adding more bands so that we can see much more and complement Sentinel data and many other use cases that we couldn't until now. Now let's talk about planet solutions for Earth observation. We basically package our imagery into 4 main products, those you can see here: planet monitoring, planet base maps, planet tasking, and our analytic feeds. So let's dive into each of those for more details. So planet monitoring is basically our flagship product, and it involves all of our active constellations. As mentioned, the Dove satellites are on a sun-synchronous orbit and they are always on, so they function as a line scanner of the Earth, as you can see in the animation here. The very high-resolution SkySat then offer a much closer and detailed look of change and can be tasked for targeted monitoring of smaller areas. The orbits and the configurations of these constellations allow for what we call tip and cue monitoring. So as the Earth rotates, our always-on Dove satellites acquire images over the landmass of the Earth non-stop. On those, we can identify regions of interest in the Earth if specific change is present. If we see something that interests us, then we can task our SkySat satellites for a closer look to see detailed change. On these slides, I'm showing the stats of those 2 constellations. As I mentioned, we offer meter and sub-meter monitoring resolution for Planetscope and SkySat, respectively. We offer 4 bands, red, green, and blue, plus near-infrared, for Planetscope and SkySat, and a panchromatic product for SkySat. As you saw in the wavelength graph before, the Super Dove imagery, we plan to have Super Dove imagery having 8 bands released this year. At the moment, and just recently, we've released the first 5th band Planetscope product containing that red edge band. So both constellations have been acquiring data since 2014. The archive, of course, of Planetscope data is significantly bigger than that of SkySat. So what if what you need is not necessarily a single or a bunch of separate images daily, but instead you're more interested in global coverage? So we also produce what we call planet base maps, which are complete and analysis-ready mosaics generated using the best planet imagery over a certain region of interest and a time of interest. These are basically seamless composites of best pixels on all of the images acquired daily, weekly, monthly, or quarterly basis. You decide the time frequency. And this is a product that can be used when scale is more important than frequency, as we can produce this for the whole globe, as you can see in the screenshot shown here. Basemaps can be pre-processed as visual products in analysis-ready rasters, so that you can use them for vegetation analysis, natural hazard monitoring or response, or other visual inspections, but also for machine learning, for instance. In general, any use case that requires large area coverage can be covered using basemaps. Our newest product is the Planet Tasking. This product gives you the possibility to direct the satellite to image your area of interest yourself using our tasking API and or our tasking dashboard. At the moment, I have to say that this is still in beta mode, so we, Planet, are still doing the tasking for you, but it is to be launched in a couple of weeks, so it's going to be very fresh soon. So given that our SkySats are very flexible and we have 15 of them, you can set up to 2 daily captures, define order fulfilling criteria such as cloud cover, priority in case you have multiple orders, etc. And we will keep tasking the satellites until that order that you place is fulfilled. The satellites are tasked almost always the same day that you place an order. It depends on the time you place it, of course, but we can try to deliver as fast as the next day. So the images are always accessible and easily accessible through our GUI and APIs as all of our other images. Now, let me stop there for a minute on the product description to go over some of the activities that we can cover with our monitoring, basemap, and task SkySat products, basically the products that I just described to you. So first, let's go over a common agriculture use case, which is field monitoring. This is one of the main use cases the satellite imagery from Landsat and Sentinel have helped with incredibly over the past years. People have been using Sentinel data to monitor crop health and take timely decisions for a while already, due to its very stable radiometric resolutions, for instance, also like the available bands, and also the cadence. But what happens when a compelling event occurs and no image is available? Meaning, the cadence of Sentinel data is every 5 days. So what happens if an event occurs in between that gap? Or, for instance, when your field is too small or higher resolution is needed to see, closer or more detailed change. And that is precisely when Planet data comes in handy. So our higher cadence and higher resolution enables us to monitor the fields continuously and at a greater detail. For instance, in this example, using the NDVI or Normalized Difference Vegetation Index, using the red and near infrared band over this image on October 30th in 2018, we can see, an indication of the vegetation health over this greater farming region. Looking at an image on the next day over the same region, we see that there's no great difference. But if we are interested in in-field or inside field changes, we need to and we have to look deeper. So when we compute the NDVI difference between both of those images, we can see that some in-field change occurred, probably caused by harvesting. Now, if you're a commodity company or an agriculture institution, for instance, using ancillary data such as yield estimates, we could infer how much production is expected on this field on a daily basis. And this within field change is only visible using high resolution imagery. And again, I just want to point out here that with PlanetScope, we can just go a level deeper that what other people have been doing already with Sentinel data. So for smaller fields, or also for higher cadency. Another example I wanted to show you is the combined use of PlanetScope and SkySat tasking and monitoring for vegetation encroachment. Sort of like this tip and cue approach that I was mentioning before. Companies such as energy providers or train operators, they need to monitor the vegetation stays safely away from their energy lines or train tracks. And in this example, we're using PlanetScope imagery to, again, compute NDVI and NDVI differences between two images at different timestamps to determine if vegetation can be found within the safety limits defined for the right-of-way on these train tracks, as in this example. So if we see an event that sets an alarm, we can even confirm by tasking a SkySat satellite and get a more detailed look on the area, and hence make it more appropriate and also timely decisions. We could go a bit step further and even generate weekly and monthly or even quarterly base maps to scale this effort to monitor the complete train line or train line network. So back to the products. The last product on our shelf that I wanted to talk about is the analytic feeds. These are the results of years of machine learning model development using a large PlanetScope archive for training and validation of those models. To be able for us as an Earth observation company to not only provide you with pixels that you can ingest into your spatial workflows, but also insights, features that can be extracted from our imagery to make your analysis easier and more streamlined. As of now, we offer two different types of feeds, object detection and image segmentation to extract vessels, airplanes, roads, and buildings on a global scale. And we do also well paths and silo bags extraction on specific geographies. So how does this work? Well, for our object detection models, we use daily imagery to extract mid-sized objects that can be seen on our images, right? So we do that on global airfield for planes, on ports and coasts around the world for ships, and as I mentioned, in specific geographies in North and South America for well paths and silo bags. This limitation is there just for now, as we are always trying to increase the catalog of feeds that we offer. So these detections are delivered to our customers as Spectre files so that you can easily manage to count, visualize, aggregate, and basically analyze to retrieve the information that you're interested in. For instance, you might be interested right now on how many planes are now stuck on a specific airport due to the COVID-19 travel restrictions. Also you might want to compare how many are there today in comparison with yesterday, with last week, etc. And this is only doable because of the high frequency and also the huge PlanetScope archive that we have. For roads and buildings, on the other hand, this is a bit different. Since we don't expect a building, or a road, for that matter, to be built overnight. So we apply machine learning models to do image segmentation, not on daily scenes, but on monthly mosaics. And that way we can deliver a more complete and comprehensive data set that shows the development on your area of interest. Of course, if you're monitoring construction of a building, you might not be interested in looking or seeing a change on a daily basis because the change might be minimal or even non-existent. So that's why we do it on a monthly mosaics. So for instance, if you want to scale a bit higher and you want, to monitor settlement development, in this example, I'm showing one in Syria, you could be able to infer, that activity is about to happen when you see new roads, for instance, and that will give you a clue that you want to monitor that area for building. That's the experience that we have looking at road construction. Normally it precedes building activity or other type of activities such as deforestation even. But in this example, having the building layer, you could even, quantify the growth in area in square kilometers on a monthly basis of that settlement if you use the building footprints. So that could be very helpful for, urban planning or even like monitoring illegal development. In this example, for instance, you can see that our roads and buildings are very useful, were very useful to analyze, track, and map the fast development on the settlement as it happened, basically, during those 8 months. I wanted to show you also to give you an idea or, an idea of the sheer size of the scale that we can go with our analytic feeds for roads and building detection, showing you this animation for a model that we developed in October 2019 for roads and building globally. So using our full global, PlanetScope's archive, we were able to detect all roads and buildings all over the world for the month of October 2019 for the first time ever. So how can you access these products? Well, at Planet, we care about making the delivery experience as streamlined and integratable as possible. And that is why we have several ways for you to access the data. So we have our own Planet Explorer website, of which we will be doing a demo in just a bit. So it is an online tool to visualize and assess data prior to download it, which you can also do in there. Pretty much as other Earth observation data providing tools, web tools. You can also use our Planet APIs to download the data programmatically. You can download images. You can also apply operation on the images, such as clipping, co-registration, etc. Or you can also, simply stream the pixels onto your application, such as a web application. And then you can use our tiles services to stream WMTS and XYZ tiles. Another way of getting access to our data, and this is what we're calling Planet integrations. As of last year, we started working with integrating Planet's catalog and pipeline directly to the major geospatial tools in the market. So we have a QGIS plugin now. We have an ArcGIS Pro add-on, and we are working on a Google Earth Engine integration. And these integrations basically map the Explorer user experience to those respective tools so that you can easily add Planet imagery to your existing workflows. Okay, this is my last slide, and I wanted to include this because it is specific for EU researchers and application developers. As of last year, Planet is part of ESA's third-party mission program, and that means you can have access to level 1B, level 3B, level 1B and level 3B PlanetScope, SkySat, and RapidEye products via ESA for scientific research and development purposes. So basically, check the EarthNet website linked in here for more information, but basically, to qualify for access, you need to be in education. You can be a scientific user, a researcher, or an early stage startup in an EU member state. You need to provide a project proposal that includes your area of interest, your time of interest, and your use case. And then after review from a committee in ESA, you will be granted access to the data that you can then access via the delivery tools that I just mentioned before, integrations, data API, or the Planet Explorer. Yeah, and with that, I come to the end of my slide deck, and I would like to move on to the pre-recorded demo to introduce you to our geospatial analysis tool, the Planet Explorer. Thank you.
Hi, my name is Luis Peraza, Professional Services Engineer here at Planet, and this is our Getting Started with Planet Explorer video tutorial. Planet Explorer is our online tool to search and analyze geospatial imagery, enabling users to see change across the planet over time. You can use Planet Explorer to search through our imagery catalog and either download full resolution images or to stream images and analyze them directly on the browser. Planet Explorer allows you to not only search and view imagery from Planet's catalog, meaning PlanetScope, SkySat, and RapidEye data, you can also access public imagery such as that from Sentinel-2 and Landsat 8 sensors. Planet's imagery is available at multiple cadences, ranging from daily scenes to weekly, monthly, and quarterly base maps. Let's have a look at some of the features of the Explorer on the browser. To navigate to it, simply open a new browser tab and type planet.com/explorer, like I have done in here. I am already authenticated, but in case you're not, you will need to use your Planet credentials to do so. This is our landing page, a world map showing the latest available global base map, which is Planet's mosaic product created with the best cloud-free scenes acquired around the globe for a defined time period, in this case, for the complete month of April 2020, all stitched together seamlessly. On the Planet Explorer, you can search for imagery by searching by location, uploading a geo file, drawing an area of interest or AOI on the map, or clicking on the timeline. To search by location, simply type your area of interest or location on the search box, much like you would do on any search engine. As you type, places suggestions will be offered, so simply find your location and click on it. The map will instantly zoom to the chosen location, and an area of interest bounding box will appear in the map view. Once you have a bounding box drawn, the result search will appear in a panel on the left-hand side. You can also search for imagery by drawing your AOI on the map or uploading a geometry file. The Planet Explorer accepts shapefiles, GeoJSON, KML, and multiple other geo formats. If you have not yet drawn an AOI, you can view base maps over time by clicking through the timeline. The month of the years are selectable, and when you click on one, the map changes to show imagery for that month. On the far right, we can scroll to the different time series available, and on the far left, you can see the list of base maps you have access to for each time series. If you have selected daily imagery as your time series option, a fixed size AOI will be drawn on the map automatically, and a search results pertaining to that AOI will show up. Of course, we can always narrow down our AOI by using our drawing tools. Now, let's view and filter imagery. Once you have defined your AOI, search results will show up in a panel on the left-hand side. This panel allows you to search for data using filters, date ranges, and choose the type of imagery you're interested in. Search results are organized by date and sorted in descending order by default, that is, most recent first. You can choose your imagery cadence, having individual scenes shown when daily is selected, and base maps for all the other options. There are options to change filter settings to narrow down the result set of images. Here you can select the type of sensor you want images from, both planet-owned and public. You can define area coverage criteria. You can make sure to leave out cloudy images by setting the cloud cover filter. And you can input your required acquisition parameters, filter criteria, and much more. To return to the imagery list, click Imagery in the top left. You can also modify the date range of your search, which by default is set to the last 3 months, by using the interactive date picker. You can also add multiple date timeframes to make sure your search is more precise. If you click on Save Search, the filters you have set will be saved for later use, and you can even set a notification for when new images become available. Planet Explorer allows you to analyze imagery directly on your browser by taking measurements, comparing pixels, and applying different indices and visualizations. You can measure distances, areas, and bearings or azimuth using our measuring tools. This might be useful to, for example, measure the length of a bridge, measure the area of the container storage facility on a port, or simply to measure azimuth directions, as shown in these examples over the port of Cadiz in Spain. If you want to analyze imagery beyond the RGB spectrum, you can make use of the visualization tools. These features, though, currently only work with our surface reflectance maps, so we need to navigate to such a product. We can easily go through the full list of available base maps and choose an analytic mosaic. For this example, we're choosing one for the state of Oregon, generated monthly since January 2019. The current visualizations are the common RGB visualization, color infrared, and normalized difference vegetation index, or NDVI, for which you have the option to select different color ramps. You can also compare planet imagery for different days, months, and quarters side by side. Click and drag any imagery from the left panel and drop them in the boxes on the map. You can see for each box, the information in the top center describes the image that has been added to the map view. You can swap top and bottom images as you wish. On the slide mode, a slide bar is visible in the middle of the map view, and you can slide right and left to notice changes between the two dates. On the fade mode, the left image will be on top, and you can change that by using the opacity slider at the bottom and progressively reveal the differences on image on the right. If you would like to compare multiple images, you can create time lapses using Planet Stories, which you can share with your network or even embed in your app. Finally, Planet Explorer is your go-to app to download imagery. You can order directly from the app or even by sourcing code requests for specific scene IDs if you prefer using APIs. Let's use the search that we just saved over Cadiz in Spain and quickly select a couple of images to download. We can just navigate to the day we want and deselect the images we don't want to download. At the very bottom of the search results panel, you will see two buttons, one for API and one for orders. Both of these buttons represent the images in the above panel that you have selected. On the API button, you will get the current request syntax that you can use to directly order these same images using a command line terminal. The Orders button will lead you to a Download Imagery window for you to prepare your order. In this window, you can select the level of processing you want your image to have. Once an order is placed, it will show up in your Orders panel on the right-hand side. You will also be notified by email about the order's progress. And once an order is ready, you can easily click on the Download button and get your images delivered to your local workstation. And that is it. We have used the Planet Explorer to search and assess imagery, analyze it using different visualization tools, and place download orders. If you want to explore more, visit our own developer center, where you will find more information about Planet Explorer and Planet APIs, such as docs, tutorials, and Jupyter notebooks that will help you get your hands in our data programmatically. I am Luis Peraza. Thanks for watching.
Well, thank you, Louis, for sharing the company insights. Before we go to the questions, let me introduce Dr. Rene Griesbach. Rene works as a pre-sales engineer and project manager for Planet Labs Germany GmbH. His special field of interest are the geometrical aspect of space sensors and developing customer solutions, especially for agriculture and forestry monitoring. During your presentation, questions were submitted in the text box. We will pick a few in the coming 10 to 15 minutes. And well, please also explain about the Copernicus Masters, of which you are a sponsor. So let me go to the first question.
Yeah.
I'm swapping screen right now for the text box. Yeah, I got a first question from Robert. Is there a way to use Planet data for students? So in a broader sense, it's like, what's the data availability, and are there differentiations to be made between groups, like students, small companies, or larger enterprises?
Yes, good morning, everyone. Yes, of course, Planet is always interested in getting especially young specialists used to our data, and we have several programs to support such research activities and maybe even master theses and so on. If you are located in Germany, then we have the RISA program, which is supported by the German Space Agency DLR. You can find it at our website, planet.com.resa, R-E-S-A. And the second way is already mentioned EarthNet program from ESA, where you can apply for data for research topics. You just have to intend in your application, describe what you want to do with the data, and ask for support by ESA. And if those things do not work, feel free to contact us directly, always with a request for data for your research work, student work, and so on, and we try to accommodate that if it is in reasonable size.
Okay, and thanks for the answer.
Let me add, Martin, to that, because we also have like a global education and research program that we don't like, and, in Europe, we go mostly with working with the cooperation with ESA via the EarthNet program. But if you're not just an individual player or researcher or developer, but you're a professor, for instance, that are interested on like making the data available to your classes, you can also apply for some of the education research program packages. We have Campus and also I think Professor. Of course, Campus gives you then not just like one class accessibility, but also to many more. So those are, yeah, like the mention, like Rene mentioned, this is just another way to get data for research purposes. Okay, thank you very much for the answer. You mentioned in your presentation, of course, Planet, but you mentioned in the answer ESA. So I would like to learn more about the triangle of collaboration of ESA, Copernicus, and Planet. So can you both please share your view on this, how this system works?
Yes, of course. Planet is based in Berlin, so the European part of Planet is based in Berlin. And as a European entity, we are always in a very close connection to ESA and also participate in all the Copernicus activities wherever we can. So I want to mention our data delivery into the ESA data warehouse, into the Copernicus data storage. We have supported since 2009 with our Rapid Eye constellation, and we usually try to participate in these EHR campaigns every 3 years to provide the full coverage of images over Europe. The second major activity in this Copernicus environment is the support of the Copernicus emergency mapping service. So Planet is a commercial part of the international agenda for the support of disaster situations, and we have a direct connection. So, or the other way around, the Copernicus emergency service has a way to directly task our satellites to retrieve data for any emergency cases. And the third direction working in the Copernicus environment is to support the Copernicus service providers for the land management and maritime services with our data, but that's always depending on the intermediate institutions like IVA and ESA.
Okay.
So just another topic, a bit outside of the Copernicus thing, we work closely with ESA in some research projects. So one of them is the European Data Cube project, which enables different platforms like the DIAS platforms and the Planet platform, so to be used for applications which may make use of multi-source data and multi-temporal data, so to enable users to work with a lot more data than just from a single provider.
Yeah. So if I may ask, how does it work? Is it that you commit yourself as Planet to one DIAS partner, or is then the Planet data available in all 5 DIAS systems which are there?
So the one goal of the European Data Cube project is to implement Planet data as the first commercial layer in Sentinel Hub. So that means that all the DSs have access to the Sentinel Hub and will be able to retrieve Planet data from there as well.
Okay. Then it's all about collaboration. Maybe as we look at the more private side of doing business, it's about everything which is in the range of larger corporates to startups. I know you are a sponsor of the Copernicus Masters. You have your own challenge. Can you give us a little bit more insight in how to collaborate with startups and how to ignite this innovation which happens over there?
Right. So this is something that I wanted to add also because it's a very important and vital collaboration that we have right now with the Copernicus program. We've been working for the last 3 years on our own Copernicus Masters Challenge and try to follow or align, with the goals of every year's challenge. And this year, we're trying, of course, to align to the try to, achieve success on the European development goals in terms of our sustainable food system and biodiversity. So we are looking for startups, like young startups, or just people with just an idea, like people that it's before joining an accelerator or anything, just basically ideas that can be developed and pitch using Earth observation data to achieve those goals for development within the European Union. I wanted to mention also that we are supporting this challenge with, technical exchange. So we have support and professional services teams joining this year to support the winner of this challenge with, integration of, the Planet platform too, like their platform, basically also trying to draft architecture of their ideas using our data. And that, plus, of course, we provide data for 6 months, access to the monitoring program, which is one of the products that we mentioned today.
Okay, and last year, your challenge winner was awarded with the overall Copernicus Masters award. How is this collaboration going on?
Yeah, we selected basically, or we also selected the one who won the complete award. And I have to note also with that if you do get that award, then you get plus 10,000 euros. We've been working closely with them and trying to make development of the data that we have. Of course, there's a lot of challenges because it's still like a very early startup. Developments are moving forward. Yeah.
Okay, good to hear. Then I got a question from Sam. It says, which functionalities can be accessed for free for testing benchmarking purposes within the Planet products and functionalities? And also, is it Planet Explorer accessible for companies too?
Yes. From the product like data or like, let's say, product catalog that I mentioned, you will have access with either using those avenues that we mentioned before for research and development, such as like SI EarthNet or Education and Research Program. You can have access to a trial, like a 2-week trial to our data for view only. That means you can see the data, analyze it on the Explorer, but also using the QGIS integrations. And also like the ArcGIS integration and well, soonly the Google Earth Engine integration. That means, you will be able to see, use the search capabilities, see the data, like apply indices on the data virtually, like on the Explorer, but you would just not be able to download it. This is something that we provide customers that want to try out, their use cases with our radiometry, like with, like just the 4 bands that we have, and also with our resolution. Right?
Okay, thanks. I hope this answers your question, Sam. Then a new question coming in from Pranav Pasari. He is from Sets and Solutions, UK-based remote sensing company startup. Oh, well, you got your first applicant for the Copernicus Masters. And then, the lines are a bit missing, but is there, I think the question is there some way to get additional information on the challenge and maybe also to have some kind of an expert view before submitting?
Yeah, you can go to get more information about the current challenge and the current application process. You can go to planet.com. And in there, we have an announcement on our landing page. And because the announcement was done, like, I think basically last week. So you'll have the information in there. In terms of a bit more information, you can have a look at that. And if you still have questions, you can contact us directly at support@planet.com, support@planet.com, sorry. And we will try to answer your questions and maybe also connect you to the people that has more information about the specifics of your questions.
Okay, and maybe I'm from the old economy, but Planet, you are based in Germany. Are there any affiliated offices throughout Europe of Planet?
So no, Planet base office is located in Berlin, but especially in this Corona time, so we are all spread around the world. So we have people sitting in Netherlands and Great Britain or in UK, in other countries, and working from remote, so to say. But there are no other offices in Europe. It's just the Berlin office.
Okay. Well, at least you know, Pranav, that you're in. You're heading into the right direction where all the information is available. Okay, then Lenka is asking, would it be possible to get these slides? Well, all the presentations are available via the website of the event, so you can see it. Or is there any other way of getting the information, or should they also reach out to you, Luis or Rene, for additional questions?
They can definitely reach out to us to me at least, and I guess to Rene as well for more information. You won't have through the this platform will be the way to get this specific slides because they were made for this presentation. But all of the information about the products and about the tools that is included there and much more can be found in our developers, our main documentation hub, which is the developer center. It's basically just developers.planet.com. It's also linked on the slides, but I reckon that with video you cannot really link on those. So it's just like developers.planet.com. You'll find a lot of information about our products, details, how to access the products. And also what I think is very good, you'll have a lot of tutorials and training guides that will show you and make you more familiar with all of the tools, APIs, Explorer, any integrations that we have. So in there also you'll find some links to our normal communication
tools like the support channel, the FAQs. But yeah, long story short, you can also contact us if you have more detail.
Okay.
If you have more details.
Yeah. Then I would like to go back to the question of Pranav again. I missed one thing, like he's asking for preparing the proof of concept for the masters. Is there any chance that data sets are available from Planet to prepare the proof of concept?
First, let me mention at that place that we have a dedicated webinar regarding the Copernicus Masters tomorrow at 10 a.m. Where these questions can be professional answered, because I'm not so deep into the Copernicus master things. But for proof of concepts, we usually provide test data for a short period of time, 30 days or so. And what we ask for is to provide us with an AOI, so the area of interest, and the estimated download volume. And at the end of such a trial, we would like to get the feedback for our own purposes to learn where you see the challenges of working with our data, what were your results, and so that we can use it in our further development. It's a case-by-case decision.
Okay, good. So tomorrow there's a webinar, that's what I understood correctly or something? Or?
Yes, yeah, at 10 a.m.
In the announcement of the Copernicus Challenge on the website that I mentioned before, the link to that webinar will be there. All you have to do is just click on that link, put your name and email, and then you'll be able to access the webinar.
Okay, very good. I don't see any questions coming in yet, but I've got one. If we look at the near future and the future, let's say over 5 years, what do you expect how the business model has changed of Planet and the use of satellite data?
Okay, 5 years is of course a long period for visioning, but we already feel now that there's a much higher demand for remote sense information in the economy. So we learned a lot of really cool use cases which we never thought about, that maybe something which can be handled by satellite. So I would say that the future is okay for satellite imaging. Area monitoring will get a growing value in the economy, especially in vegetation sciences, so that's agriculture and forestry. If you just see the insect infestations all over Europe now with this bark beetle and so on, so satellite image is just the best way to see that from top. Instead of sending a forester into the forest, it's much more economical and viable, and it does the job. So we don't want to replace the specialist on the ground, but it should be a helping tool and information, a guidance to do the job better and faster and more effective.
Yeah. Okay.
I wanted to mention also that, like Rene mentioned, and I think you noticed that, for us, 5 years, it's it's a lot of time. Because I was mentioning in the presentation, we try to go really fast with, trying to keep the technology in this agile approach. I think some things that we've noticed in the last 5 years as we launch more satellites is that we have to, at least for example, in Europe, there's a lot of data that is very useful already for the use cases that, some of the use cases that we cover with less resolution. I'm talking about Sentinel data. When you bring then higher resolution, there's another gamma of use cases that become available. And so mixing, those different type of data or those data sets, they just manage you or allow you to cover a much more wider field of use cases. And that's what we are focusing on right now a lot, making our data much more interoperable. It's a very difficult word. And so that we can complement, use cases that people already have been having for a long time using Landsat and Sentinel data, but now with higher resolution PlanetScope data.
Yeah. Okay. Does it mean also you that you will buy information from third parties, for example, from drone companies or from companies who own the in situ data, so to present the different data layers which might come to the solution, in which satellite data is one aspect?
And no, I don't think we want to go that way. So I already mentioned this European Data Cube, and that's actually the vehicle which is built for such task. The Data Cube will collect all this data from different inputs on different platforms, from in situ data providers and so on, and provide it as application ready to one of the DSs or other computing platforms to retrieve the special results or this value-added product from there. So Planet itself will not start buying other data and distribute it via our platform.
Yeah, okay. Well, I see no new questions coming in from the participants. Maybe you can share some kind of a vision on or what kind of future applications you might be keen on to develop, or maybe some invitation to the participants of this session to think of some topics.
Mm-hmm. So where I see a bigger potential, or the biggest potential for growing, is, as Luis already mentioned, in the sensor fusion sensor connection, putting everything on a multi-source layer. And this may be other optical satellite data like Sentinel, Landsat, and so on, but also radar images. I think there's a big potential in combining optical with radar imagery, not only for the usual purpose that, a radar satellite can look through clouds and so on, but really for classification purposes. So we can add some more features, object features into classification scheme if we extend our database or the source database for that. That's one of the biggest potential I see. And then the extension into new areas where satellites were not used before. So that we call it business intelligence. So you can see use cases that somebody wants to predict the yield and the worldwide yield on some crops. And that's already helping in decision making. So for the worldwide food security, where to buy corn or so, where's the highest yield this year, and so on. And we will see challenges in the worldwide food supply and security and so on. And I'm pretty sure that the role of satellite data in all these fields will grow over the next time.
Okay. We are pretty much looking forward to hear and to see what people is doing with Earth observation data. I don't know if some of the people participating in this call participated also on the NASA Space Apps Hackathon happening on the weekend, which was basically focused on trying to find solutions on how to tackle the current normal of the current COVID-19 situation. This experience and many other just brings a lot of new use cases that you can think of that were never worked on with remote sensing data. And there's many avenues that we have to make this data available, like we've mentioned it. And also we have a lot of platforms to allow you to let us know what is the best way to work with this data. So in this year, and we already opened calls for our Explorer conference that is going to happen in October. It's going to be completely virtual. Along that Explorer it's our user conference, but along that conference is going to be also like a Planet Hackathon that takes 2 days. On this hackathon, basically you bring your ideas, and it's hosted by Planet. We give you all of the data, you have access to the pipeline platform, and then you can either come and prove your use case or validate your use case with our data, but also just come and develop kind of like that idea, like crazy idea that you woke up within your mind one day. But okay, like what I want to say is there are platforms, and we want also to integrate our work, like our data and our pipeline, into all of the workflows that exists right now. That's why we're working right now very heavily with Google Earth Engine, because we know this is something that a lot of researchers and developers are using. But if you have any tool that you normally use with, and or it's very complicated to use Planet data, for instance, you can always let us know at support@planet.com. We're all ears trying to integrate our data, not only just in the sensor harmonization kind of thing, but also on the available platforms that exist and people use it.
Okay. Thank you very much, Luis and Rene, for the very extensive answers. So it's good to learn that you're all ears and open in the world of working jointly with you. let's do a final check on the question box. Yeah. Oh yeah, Melda is asking, do you have a program for PhD researchers? For example, short-term residency, mentorship, and so on. Is that something which Planet also facilitates in?
It's difficult. So, but we have an internship program, and such an internship can be used to finalize PhD thesis and so on as well, and be supported with our data while this person is working in the company. But we don't have a dedicated PhD program in mentoring that's then somehow decided in the teamwork and so on once we have an internship relationship with such a PhD. But feel free to apply. So we like to review and really like to work with young researchers and get fresh ideas into the company.
Yeah, I think to add on that, the internship program is basically that only tool that we have for kind of mentorship, and that basically just gives you access, to all of the experts and engineers that are within the company. But yeah, like Rene mentioned, I wanted to second that. I think you just let us know. I think it's also like a very interesting way of doing it. Yeah.
Okay. Very good. Well, thanks for the explanation of all the questions. And I think as there's no questions, we still have 2-3 minutes. So in case you want to share something or else, I would suggest to close the session. Yeah. Okay. So this brings us then to the end of the. Sorry, Luis.
No, I just wanted to add, I wanted to repeat the things that I was mentioning before. There's a lot of events. There were a lot of events that got canceled this year, and I'm happy that a lot of people showed up to this very interesting virtual event, and they kind of, followed through to the new format of just submitting your questions in a box. And I hope we could answer those questions. And as we were mentioning before, we are there at support@planet.com. You can go at developers.planet.com, but you can also link us or reach out to us directly through our emails if you have any questions.
Okay. Well, Luis, thank you very much. And Rene as well for this session about Planet, but also about how you engage with the industry and with new people. So thanks again. And thanks you all out there for joining this session. And we will hope you will join us this afternoon as well, as our program of the roadshow lasts up until 4:30. And don't forget to use the hashtag #DOE-roadshow. Well, thank you for contributing and participating, and I hope to see you again later today in a different session. Thank you very much. Bye.
Thank you very much.